Let's now look at an axiom that may seem so obvious that you'd be completely flabbergasted or surprised that there are any voting methods that don't actually satisfy this axiom. And the idea is that if there happens to be any sort of consensus in among the voters, then that absolutely should be reflected in the group decision. So the idea, this is called unanimity or weak Pareto or Pareto efficiency. There are different names for it in the literature. And the idea is that if everybody in society agrees that there's another candidate that is ranked higher than candidate A, then candidate A should not win the election. I don't know if this other candidate should win the election. There may be good reasons why that candidate shouldn't win the election. But whatever those reasons are, definitely candidate A should not win because it's unanimous. Everybody agrees there's another candidate that's better than candidate A. Now, why would you this seems absolutely obvious, why would you even imagine situations in which this is not actually satisfied? Well, there's different ways to make precise this idea of unanimity. And here's one stronger statement, namely, suppose that we have a group of people, and some people rank X above Y, while everybody else is indifferent between X and Y. Then the requirement is that society should reflect that consensus, that there's a bunch of people that don't care. They have no preference over the ranking of X over Y, but there's people who do care. And so society should reflect that by ranking X above Y. Related is this idea of indifference, that society's ranking of X over Y should be the same whether or not we include voters that are indifferent between X and Y. So this is a bit stronger. So the idea is that you look at all the voters, if you're interested in ranking just X and Y, you throw out everybody that's indifferent between X and Y, and you use the remaining candidates to determine who the winner is. So again, these seem very natural from a certain point of view, but let me suggest that there's at least one situation in which you may not want to impose something as strong as strong Pareto or indifference. So imagine that you're ranking two alternatives, and there's 1,000 people in the group, and everybody in the group has judged that one alternative they're indifferent between both of the alternatives. But there's just one voter, just one person, and that person happens to rank the first alternative over the second alternative. What strong Pareto will force is that society has to align itself with that one voter. And maybe these are not necessarily just expressions of pure preference or value. These are judgments about which alternative is better in some objective sense. And everybody, all the 999 people really did their due diligence, and they really went out and they gathered as much evidence as they could, and they realized that there's no way to rank them. They're both equally good alternatives. And this other person just happened to flip a coin and said, oh, okay, well, I'll rank X above Y. Now, if everybody's truly indifferent, then maybe this shouldn't matter. Maybe this is fine if society really has to choose between one of the two alternatives. But maybe the fair outcome is that society should be indifferent between X and Y, rather than aligning itself with that very, very small minority, just the one person who ranks X above Y. But in any case, strong Pareto and indifference are stronger than this unanimity condition, which I've mentioned here, because unanimity just says if it happens to be the case that there's another candidate that is ranked strictly above candidate A by everyone, so everyone ranks this other candidate strictly above candidate A, then candidate A should not actually win the election. So let's see an example of a failure of unanimity. So we're going to say that a candidate is Pareto dominated in a profile of voters if there's another candidate Y such that every voter ranks Y above X. So this is just this idea. There's this candidate X and it's dominated, Pareto dominated by another candidate. So for example, here's a very simple election with 4 candidates. And note, everybody ranks candidate A above candidate B. So it's unanimous. Everybody agrees that candidate A should be ranked strictly above candidate B. However, if we were to use approval voting, and it just so happened that this voter approved of his top 2 candidates and everybody else approved of their top 3 candidates, then the approval winners would be A and B. Now, this doesn't mean that a Pareto-dominated candidate is guaranteed to be elected, but it depends on the tie-breaking rule. The tie-breaking rule may be just a flip of a coin, flip of a fair coin, and so with probability 0.5, candidate B may end up being declared the winner. And that would mean that a Pareto-dominated candidate could possibly be elected. Well, we can look at another voting system that will actually guarantee the election of a Pareto-dominated candidate. And this is a voting system we haven't talked about yet. It's called successive elimination. And the idea is that voting is going to be conducted in a series of rounds. And in each round, you just pick 2 alternatives and you compete those 2 alternatives against each other. And whoever wins moves on to the second round and competes against another alternative. And whoever wins moves on to the third round and so on until you have just one winner. So it's the usual idea of a tournament. So in a usual sports like a basketball tournament, you have 2 teams play each other, and the winners move on to the next round, and the winners move on to the next round until you have the unique winner. So in successive elimination, you need to pick an agenda, the order in which the alternatives compete against each other, and then once that agenda is fixed, you can then run this successive elimination voting procedure. So let's look at an example. If you fix the agenda in the right way, you can actually get a Pareto-dominated candidate to be elected. So here's a situation, exact same situation. We see that candidate B strictly dominates candidate D, meaning a Pareto dominates candidate D. So everybody, all 3 voters, strictly prefer B over D. So it certainly would be odd if we could somehow get candidate D to be elected, but here's a way you could do it. You use successive elimination. And the agenda is, we say, well, let's compete A against B to begin with. The winner of that competes against C, then the winner of that competes against D, and then whoever wins that is going to be declared the winner overall. So what happens? Let's look. Candidate A versus B. Well, when A goes up against B, we see that a majority, namely 2-1, 2 people prefer A over B, so A moves on to the next round. Now A goes up against C, and we see that candidate C moves on to the next round because the majority of people prefer candidate C over candidate A. And finally, when C goes up against candidate D, we see that candidate D ends up beating candidate C. So D is in fact declared the winner. But that's a bit odd, of course, because we see that candidate D is Pareto dominated by candidate B. And of course, what's the trick? The trick is to manipulate the agenda or set the agenda in such a way that the one candidate that candidate D can beat ends up making it to the round so D is the last person. D is the last alternative you consider, and then you just set it to guarantee that candidate C goes up against candidate D because we see that D would actually beat C in a head-to-head election. So this is certainly counterintuitive. Many people view this as a knockdown argument against using successive elimination, or at least you have to be aware that the order of the agenda has a direct effect on who actually wins the election.